Hi, this is Shully Physics getting you started on linear motion practice E number 4. Got Stephanie hitting a volleyball from a height of 0.8 meters, and she gives it an initial speed of 7.5 meters per second straight up. So we're trying to find how high the volleyball will go and how long it will take to reach its maximum height. You see how it's really pointing to the top point? Like how high does that ball go? So in this situation, we're starting again with a person similar to the last problem, number 3. Here she's taking a volleyball and hitting it up. It's going to go up to a maximum height. And this is really what we're looking at up here. How high is it going to go? It starts at 0.8 above the ground. See that? 0.8 meters. So it has a starting position. We haven't really talked about starting positions that are non-zero before. So there's going to be one little added piece here. So I'm going to call this a y0, the initial y value. And we also know the initial velocity, she hits it at 7.5 meters per second straight up. So first off, this ball is going to be slowing down as it reaches that top point. And later on, it's going to speed up. But this problem's not really looking at what happens as it falls, just looking at what happens as it goes up. Increase our, there we go. So what else do we know? What else is implied here? Of course, acceleration due to gravity is 9.8 meters per second squared. But let's consider, should that be positive or negative? If she's hitting it upwards and gravity's working down, then we should make gravity's acceleration the opposite direction of the starting velocity. So now it's going to decrease its speed. Its change in velocity will be negative. All right, so that's important to know. But we need to know how high it goes. We need to know like the final y, how high it goes, and also how long it will take to get up there. Those are our unknowns. All right, so if we start thinking about how to approach this, what do we need now? Let's look at the equations available to us. We need to know how high it goes. So that's an x or y value. Remember, x and y are interchangeable. We're just talking about a vertical distance and vertical positions instead of horizontal. Horizontal is x, vertical is y. So wherever you see an x in these equations, you can also think y as well. Hopefully you're not thinking, why am I doing this? And of course, that probably came across your mind. Anyway, so if we're looking for that final y position, we could look at, let's see, the first equation doesn't have an x or a y in it. The second equation does. X equals initial velocity, we have that. But right now we don't have the time. T is unknown to us right now. So let's look down at that third equation. Final velocity squared equals initial velocity squared plus 2ax. So we have the a value right there. We have acceleration due to gravity. X is the y value we're looking for, like the final, right? We have the initial velocity is 7.5, but we don't have the final yet. Do we have the final? Well, let's look back. Let's think about the situation. Do we have the final velocity at the very top? It's not given, but if something's tossed upward, doesn't it need to stop before it comes back down again? Like if you toss a pin up, it had to slow and then speed back up. So it's slowed down to what? Its final velocity at the top is 0. It has to stop going up before it starts going down. So its motion is stopped at the top. Our final velocity at the top is 0. There we go. So that's always implied. Whenever something's tossed upward, if you're trying to figure out something about the top point, know that the final velocity or the velocity at the top is 0. So now I think we have something we can use here. We have final velocity squared equals initial velocity squared plus 2ay. Now, before you move on, there's a starting y and a final y. So what is this, or where is it coming from? You might recall a little while ago talking about like average velocity is a change in position over change in time. That's really a an x final minus an x initial, just like this was a time final divided by time initial. All right, so this y down here is really a change in y. All right, and usually the initial y is 0. So we usually just kind of cover that up, the starting point 0. Like at the beginning of a race, how far have you gone? You've gone 0. You're at the very beginning position. So we'd usually cover that up. But in this case, we're going to need that whole thing, the final minus the initial. So just to get you started, use this equation, same one you've tried out before. But we're going to change this to a y final minus y initial. Now from here on, plug in the values you got, give it a go. You've got the final velocity is 0, the initial velocity is 7.5, don't forget to square that. The acceleration is a negative 9.8. Our y final is the unknown, and the y initial is 0.8 meters. And that should get you started.